Oh, by the way, just one small detail. We'll have the presentation art afterwards, so.
Hello? Can anyone hear me okay? Yes, okay, cool. I have a bunch of slides, not a lot of time to talk about them, but hopefully, we'll get through it without me speed running through it. All right, so you've probably seen, if you're a bug bounty hunter, if you're a pen tester, you've probably seen this, or a certificate search engine, where you can type in a domain. For example, I typed in tesla.com, and I got a bunch of interesting domains for me to, if I want to pen test, if I want to find a security vulnerability, I can do that. Yeah, this is, again, I'm not sure if you've seen this. If you've worked in offensive security, you most likely have. If you haven't, I encourage you to test it and put your own domain in there. What is this, in fact? So where does this information come from? I showed you crt.sh. There's Census also has a search engine for certificates. There's SSLmate, there's CaliDog, Security Search Stream, etc. Some of them have web APIs, some of them have search interfaces. This information all comes from a thing called certificate transparency logs, and it's freely available. You can either query it indirectly through these sites, or you can actually go and collect it yourself. And so I want to talk to you about CT logs, and I want to show you that they're much more useful than just for pen testers. There's a lot of interesting things there, and I'm encouraging you to take a look at it for a number of reasons, which we'll go through. I don't know what just happened. All right, so first I want to put you guys on a trip back to 2005, 2010. Some of you, like me, were working already by then. If so, you probably have a little bit of a back pain, so do I, so I'm with you. And there were quite a few things different. There were some different buzzwords, and one of those buzzwords was public key infrastructure, TLS, digital certificates, sign your documents, secure your website. Just with $9.99, you can secure your own website with SSL. It was not NFTs or blockchain or AI. It was a different buzzword, but the same vibe. Companies were formed around this. There was an economy around this. And so, yeah, people were selling certificates. And, this hasn't changed much from then. You basically, if you want a certificate, you go to a certificate authority. By then there was, Fauty or GoDaddy. I think they already existed by then. You usually pay them a little bit of money, not much. Now you don't pay at all, maybe, if you go to Let's Encrypt. But yeah, you go there, you get your identity verified. You say, hey, look, I own this website, I own a certificate. Please give me a certificate. They would do their own checks, in their own way, not really a standardized way of doing that. And they would provide you with a signed certificate by the certificate authority, and you would get a certificate. And you could prove to others that you were who you claimed you were. There were root CAs or certificate authorities that were trusted by default by your computer, by your Android, by then, it was starting, by your Windows, etc. They didn't issue all of the certificates. They couldn't. There were just too many certificates to issue. So they would create special certificates that would delegate that trust to intermediate CAs or subordinate CAs, however you want to call them. And so you end up trusting all of these. You don't know exactly how many CAs you trust. You have a bunch of root CAs in your phone or in your computer, but you really don't know how many CAs you're trusting. You also don't know where are they. They could be in Russia. They could be in a completely different country than yours, with different geopolitics, different real-world security, right? And also by then, this is very generalizing, but by then there weren't many restrictions of what a CA could issue. If, a certificate authority somewhere wanted to issue a new certificate for google.com, they could. No restrictions. This created a big problem because certificates were only seen by people who needed them. If I went to a website, I would have to see a certificate. That would be between myself and that website. That's a problem. So basically, what I'm trying to say is, if you were able to trick or bribe a CA, maybe in Russia, for example, or another country, to issue a valid certificate for bankofamerica.com, you could effectively become bankofamerica.com for a selected group of victims. You were inside your network, you met in the middle of your network, and essentially you would see all the traffic, and you could effectively convince them that you were that website. And nobody would know any better. This was a problem, and there was a lot of situations that happened between this time, around this time, enough situations that triggered this organization called Electronic Frontier Foundation to release a study and to perform a study where they wanted to scan the internet, find as many certificates as they could find, and identify the chains of trust. Like, take one certificate, let's see who issued this certificate. Let's go back to the root. Let's see how many CAs are actually issuing certificates, right? It turns out that by that time, around 1,500 distinct CA certificates were actually issuing certificates on the internet, and those were trusted in one way or another by Microsoft or by Firefox browser, etc. That would amount to a little less organizations, 651, one of which was Marks and Spencer, the guys that make sweaters. I think they're still around. So I gave a presentation about this like many, many years ago, and I used to say, by this time, the security of the internet depends on the security of Marks and Spencer group. And lots of other groups, by the way. This is not a single situation. By the way, the study is still up. It's a really interesting study. You can go look for it. The URL's right there. So then a year later, coincidentally, a year later, 2011, DG Notar, which was a CA, a root CA in the Netherlands, gets hacked. And this is, by the way, not an isolated incident. This is kind of a cathartic moment that was the culmination of many, many smaller serious issues, like certificates being misissued. Some guy pretending to be Microsoft that gets a code signature certificate, for example. It's too many situations to mention. But this was kind of the moment where people kind of stood up and said, yeah, this is not great. This is bad. Basically, DigiNotar gets compromised. And by the way that they found this was just one single reason. They actually, the attacker, presumably someone from Iran, at least they attacked people from Iran. They issued a bunch of certificates for many, many high-profile websites, including Google.com. And they managed to man in the middle most of the country of Iran and basically collect credentials, Gmail credentials, for at least 300,000 users in Iran. And there were also other users affected outside of Iran. Obviously, this was found. By the way that this was found was because Chrome was already around, and Chrome was doing an additional check for the security only of Google.com domains. You know, Google Chrome, Google.com, let's check. And they were presenting like a different error, and someone from Iran said, you know, this is weird. This is a valid certificate. Why am I getting this error? And that's how they got it. I think, to me, you know, we had WannaCry in 2017, approximately 300,000 machines infected. WannaCry was more disruptive. This was more insidious to me. This was really, really, these guys were caught almost by accident, and they wouldn't have been caught if they just continued to sniff other types of credentials. So, yeah, around this time, people said, yeah, this hierarchy, this PKI chain of trust, this is not going well. Something needed to change. So enter certificate transparency. This was the big change that has started to be introduced to try to change this. This was launched by Google officially, 2013. It's basically an effort to have a public record of all publicly issued certificates that are trusted by root CAs. It's now enforced, and by the way, this started in 2013, we're in 2025. Things are still moving here. There's not complete support and adoption for this technology. So in Chrome, it has been enforced for all certificates that were issued after 2018, and it started on 2018. They started earlier with EV certificates, but now they're completely supported. In Firefox, they started this year, like earlier this year. They knew about certificate transparency. They only are enforcing it since 2025. In operating systems, the situation is a little bit different. Certificates are used in Apple applications, in macOS applications, iOS applications. They actually have, as far as I can tell, they are requiring it since 2018. In Android apps, it's supported, but you have to opt in on a per app basis. If you're using an app that uses certificates, you might not be using certificate transparency. You need to opt in. There's an option in the SDK. It is implemented in Microsoft since 2024. I don't think it's enforced, as far as I could read, in the Microsoft operating system. In the browser, it is, because browser uses Edge, uses Chromium, so it's the Chrome engine. So hopefully you haven't seen this error. If you have a trusted certificate that is not in a CT log, which is a very, very weird thing to have. But yeah, this is the error that shows up if you have a bad certificate with regards to certificate transparency, and you won't be able to continue to the website. The way that browsers and clients check for the presence of a certificate in a CT log is, I can try to explain it really simply. It's basically used a TLS certificate attribute that is embedded within the certificate and is signed by the logs that contain that certificate. And so you can basically check for the presence of the certificate in a log without actually having to go to the log and say, hey, have you seen this? You can actually just look at the certificate and see it, that it has a receipt that it was published on a CT log. So basically, certificates are issued in the same way that they already have. You don't pay money anymore, I think. I don't know if you do. You're probably not doing the right thing. You can go to Let's Encrypt and they'll give you a certificate. But yeah, you send a certificate request. You get a verification. Hopefully, the verification is a little bit better. I won't talk about it. But yeah, and the CA will send a pre-certificate to a CT log, or to more than one, actually. It will get a signed certificate timestamp back, and it will include it in the final certificate to you. And you'll have that certificate that you can use regularly. There's a catch here that I won't go through, otherwise you guys won't be able to have snacks. But it's a chicken and egg problem, because you have to send the certificate to the log, but you also have to embed the receipt in the final certificate. So there's a thing called a pre-certificate that gets submitted first, and then you get a receipt back, and then you generate the final certificate. It ends up working, by the way, but what happens is there will be a lot of pre-certificates in the CT logs, which is a good thing. It's basically the same information. So, does certificate transparency prevent certificates from being misissued, or a random CA in Croatia from misbehaving? No, it doesn't. However, does it help detecting misissued certificates or misbehaving CAs? Yes, absolutely. But there's a catch. You must look at the logs. Otherwise, they won't be catched. There will be the logs themselves. They are not enforcing anything. They're just saying, yes, I got this certificate. It was issued by a CA that I know about. I'm not sure if it's good, but it's here for everyone to see. Here's an example of certificate transparency working correctly. Cloudflare has a service, you probably used it, DNS over TLS. There's a bunch of services that sit on a very special IP address, 1.1.1. That IP address has had a certificate issued this year and last year. They signed a bunch and they issued a bunch from a root CA trusted by Microsoft in Croatia. All right? They've done that, and they actually submitted the certificate to a CT log. So, and by the way Cloudflare caught this, at least that I could tell, is that someone alerted them. Like, they say, hey guys, you've seen this certificate? You probably need to check this out. This is not you, right? So yeah, these certificates that were issued by FINA, a Croatian's root CA, they could potentially be intercepting traffic from you to Cloudflare without you trusting and knowing, being anyone the wiser. They said, they come up and said, hey guys, sorry, this was a mistake. We did the test, and yeah, we revoked the certificates already, it's fine. Should you believe them? I don't know, I'll leave it up to you. Microsoft apparently does believe them, so they're still a root CA at this point, despite this mistake. Cloudflare got to know, yeah, because they basically had someone tell them. It's just ironic because Cloudflare owns a CT log, and they actually probably had it in their logs. But we'll get to that. But kudos to Cloudflare because they've done really good work around this. So, I know, I mean, I kind of explained how they work, but I want to show you exactly because so far it's been like an abstract thing, like CT logs, you know, what's this? Is it a server? Is it like someone with a text file or a database? What is it? It's basically, you can actually take your Chrome browser, actually go to a website that is used by Chrome, and that's, I think they even distribute this file in the Chrome distributable. That contains a list of all of these logs that are trusted by the Chrome browser. They are basically cryptographically verifiable, append-only public ledgers of certificates using a thing called Merkle trees, which is really interesting. I have a few slides about them. I won't show them to you because otherwise I will, spend the rest of my day trying to explain those. Basically, they can be accessed by everyone using a public API. It's in an RFC. This is literally a web API. You can curl it. I'll show you how. You can download certificates, and funnily enough, you can actually submit certificates to a CT log. I haven't tried, but I have seen that it's possible because you'll see. By the way, the CT logs will usually not make a lot of verifications about the certificate. They will just, for them to accept your certificate, it needs to be coming from a root CA that the CT log recognizes. So yeah, Google, Cloudflare, DigiCert, a bunch of others own CT logs and maintain the CT logs. Think kind of a blockchain, but for certificates, but without the proof of work and the massive amounts of computational waste. And it's not distributed; it's basically sitting on their servers. So yeah, these are just a couple of queries to a CT log from Google. It basically collects certificates that were issued on the second half of this year. And you can see the size. It's, I don't know, maybe 250 billion, 2.5 billion. I don't know. It's a big list. That's the first line. That's the tree size, the number of nodes in the tree. Each node corresponds to a certificate and its associated certificate trust chain. So if you submit a CT log, you have to submit the certificate itself and all of the certificates that lead up to a trusted root. And then I'm getting an entry, a random entry, which gets me the leaf certificate as well as the certificates in the chain. So some statistics about this public ledger, or these public ledgers. Each CT log is basically a distinct ledger. If we take all of the lists that exist and that are trusted or have been trusted by Chrome, it's about 186 URLs. which means there's a total of 48 or almost 49 billion certificate entries or leaf certificates in the logs. A lot of this data, by the way, is duplicate, and I'll explain why. But yeah, it's a lot of data. If I made a very back of the envelope math, and it's about 200 terabytes of data, if you want to download it, it will take you a while. And yeah, we made some infrastructure and plumbing at BitSite, and thank you to João, who is here in the audience, who helped a lot with that, and I would not be able to give this talk without the data that he collected. So yeah, it's a lot of data, but it's interesting data, I think. And by the way, what I'm going to show you now a couple of tests, a couple of ideas that I had, things looking at the certificates, and this is really just scraping the surface here. I basically took a month of data. I took the month of September 2025, and I took 30 CT logs, the biggest ones, and just looked at the data. We deduplicated the data. Again, I'm sorry, I didn't tell you this. Like, for Chrome to accept a certificate, it must be present in at least 2 certificate logs. So the information, the 200 terabytes, is at least half of that is unique certificates. And it tends to compress a lot more, but you get it. So yeah, I took the data for September 2025. It's about 720 million certificates, unique, and used the help of the big data gods, Spark, Athena, really nice guys, and we just looked at the data. By the way, I will name some companies here. They haven't done anything wrong. It's literally, they just issued certificates, and that ends up showing up in public data, and that's the reason why we're here. First, I looked at, first thing I popped into my eyes were Cisco phones from 2016 were in the CT log data from September of 2025. Why? I don't know. My theory is that someone submitted those certificates to the logs, just testing stuff out. The reason I found this was that certificates can be issued for domains. That's the very, very most frequent reason why you get a certificate. That's why you see, by the way, almost 500 million distinct host names in this data, just 1 month of data. You can get certificates for IP addresses, even though that's much, much more rare. But you saw, we can get certificates for 1.1.1. You could get certificates for emails, but no one is using certificates in emails anymore. SMIME was a thing back in 2010s to 2005. URIs are a special field that had this data on it. I Googled it, and yeah, it's a model and serial number for a Cisco phone. By the way, these certificates were issued in 2016. They expire next year, and they're old. They're like, the signature algorithm is bad. It's using SHA-1, yet a log accepted it and said, yeah, this is valid. This leads up to a trusted root, so we will accept this. They take 10 years to expire. So yeah, it's not a good certificate by today's standards. Another thing that I found, and this is something that is a bit of a trend. This is not the only company that does this. There are many, many others. So Automatic.com appears to be, I haven't known them, but they seem to own WordPress.com, the platform, and they also, if you want to host your blog there, they will. They have a cloud service, right? WordPress, Tumblr, WooCommerce, etc. If you take a certificate log and you search the database for certificates issued to the subject common name tls.automatic.com, there's a couple of ways where your host name can appear on a certificate. It can appear on the subject, or it can appear on the subject alternative name, which is another field of the X509 certificate. So basically, they issue all certificates for their clients with tls.automatic.com in the subject name, and then they put in the customer's domains in the subject alternative names. So basically, you can single out all domains that are using automatic.com as a platform that may be using WordPress or Tumblr or some other thing, right? So interesting, right? If you're a bug bounty hunter, if you're a pen tester, if you have a 0-day for WordPress, this is a nice place to start. Also, this was actually the very first thing that I saw, Imperva. Imperva does the same thing. They basically have, they generate certificates. By the way, for some reason, some certificates have a validity period of 1 single day. Don't ask me why. But basically, you can single out customers of Imperva, just the Imperva Cloud WAF, Cloud Web Application Firewall, I think. Haven't looked deeply, but I did try some of these host names that we found. And yeah, this was a situation. This guy did not have his site working, but you get a page from Imperva saying, hey, you can reach the final website, but this is a WAF from Imperva, so nice to have you here. And there's the certificate. You can see imperva.com as a subject common name, and then the subject alternative names contain a bunch of other domains that are domains that are hosted by this WAF. Also, certificates, there's a bunch of other fields in the certificate, right? There's what's it for? Is it for server authentication, for client authentication? I couldn't even parse some of them. There were some object IDs that I didn't know about. My parser wouldn't tell me what it was. There's a random code signing certificate from a guy in Cyprus. I redacted his name just for, but yeah, it was the guy that wanted to develop open source. So we asked for a certificate. He asked this issuer certain code signing CA. They got him a certificate. So this is nice. You get to know people that develop code just looking at certificate logs. This key usage, PK, init, KDC, and MSS smart card login, it looks like, from looking at it, just a random handful of certificates. These seem to be Microsoft domain controllers, that when you set them up, and you set them up with a certificate, they will generate a certificate with these characteristics. So if you're looking to find Microsoft domain controllers, maybe you'll find them here. Another thing that I did that, it was, I'm taking too long. So yeah, this is basically a rehash of the study of 2025, done in a different way. So I wanted to see what is the current tree of the chain of trust that exists from root CAs to subordinate CAs. And yes, they scanned the internet in 2010. I basically collected certificates from CT log crawling. They found 1.3 distinct CAs, 1.3 distinct certificates. We found 720 million certificates, so a little bit more. Some of them are pre-certificates, which might be, there's maybe a duplication here, but at least 337 certificates. Right, much more data, right? And we didn't have to scan the internet, which was great. They found almost 1,500 CAs. We actually found fewer CAs, which is interesting, but it makes sense because by then, PKI was a business. People wanted to have a CA. There were companies basically being profitable selling certificates. Now it's Let's Encrypt and a few others. Google issued certificates, that sort of thing. This is me I put this on a Neo4j database. I could query it. The nodes are kind of encoded by the number of certificates that they sign. Let's Encrypt is obviously the big winner here. This is me just looking for CAs from Portugal. There's two. One is Marketware. I don't know. I forgot. It's a big one. The other one is these guys that make emails. They issued 2 certificates in the month of September. Company called Suma. I don't know if anyone works here from Suma. No, maybe not. I think it's an email company. Another thing that I want to tell you about, so you probably don't want to start downloading 200 terabytes and indexing them into a database. It's going to take a while. So you could use a really cool tool that Cloudflare built called Cloudflare Radar that has a bunch of data on certificate transparency. You can't do these more in-depth queries, but you can actually look and see stats about certificates being issued, their validity, a lot of other cool stuff. And I want to subtly brag about the fact that we see a little bit more than Cloudflare. For some reason, maybe this is a rounding error, maybe this is dates, but yeah, I filtered the data for September, and we see a few more million certificates than Cloudflare, which is nice. At least the numbers match up, roughly. So yeah, I'm almost at the end, sorry. I have a lot of ideas for future work around this. And again, this is really just scraping the surface. You could do machine learning, unsupervised clustering, for example, taking certificates, grouping them by, creating a feature vector, and then clustering them using an unsupervised machine learning algorithm just to see graphically which certificates are more similar to each other. So we can potentially find other clusters of interesting data. So that's one. Second one is finding different certificates issued for the same subject domains. This is, if I were a customer, like if I'm the customer here and if I'm wanting to secure my network, that's the first thing I would do. I would be constantly looking at, for my domains in the CT logs, let's say, bitsite.com, and looking at the certificates. And for some reason, when I see a new certificate issued for bitsite.com, issued by a different CA that I use, then I'll be worried, and I'll probably investigate that. Finding certificates posted long after they're issued. Why are people posting certificates here from 2016? Good question. I'm probably going to dig deeper into that. I think that's an interesting one. So, let's end this. Basically, the title of the talk is Watching the Watchmen. Who are the Watchmen? Well, CT logs are the Watchmen. They're basically here collecting all your data, looking at what CAs are actually doing. Are they misbehaving or not? Who watches the Watchmen, basically? Who is looking at the logs? Hopefully, you, right? Or us. We need to be looking. Otherwise, if a tree falls in the forest and no one's there to hear it, does it make a sound? Probably not. So the only reason why these guys at FINA CA got caught, like mis-issuing a certificate for Cloudflare, is because someone was looking at the logs. And generally speaking, there's blockchain today, and there's a lot of companies just looking at blockchain data. I don't see, there are some companies looking into this, but I really would love to see more folks looking at this data set, which I believe is one of the most interesting data sets currently publicly available. Like, it's by far the highest number of key material that's out there that you could just download for free. And so, yeah, that's it. That's my talk. Thank you. Any questions?
Okay, thank you, Luis. Thank you, everyone. Let's go for break. We'll be